All right, review for final number 8. We are near the end, people. You keeping up with everything? You feeling more comfortable? I'm hoping so. Okay, inverse of each function. I know we just did one of these at the end of the last one, but this first one looks a little weird to me. So let's switch up those guys. And again, we're trying to get y by itself, right? So we've got to do an opposite to what's being added. Don't worry, the fractions are going to get taken care of here in just a second. Okay, so I get to this point and I'm trying to get y by itself, and I'm like, I am not a big fan of all of this stuff. Some of you at this point are comfortable enough to multiply by the reciprocal, to multiply both sides by 4/3 and just go at it. And if you can, bravo, I would do that. That's the fastest way. But for many of you, this whole thing with fractions doesn't click that way quite. So here's what we're going to do. We're going to take care of this bottom part of the fraction first. So we're going to multiply both sides of our equation by 4. Okay, that'll take care of this on this side. So I'll have 3y. Over here, I distribute it. So 4x. And then when I get to here, 4 times 3 is 12, divided by 4 is 3. Now, if that's, again, not something, it sounds like I just talked in a foreign language to you, go to the calculator and just do 4 times 3/4. Okay? And get the answer that way. And then my last step to get my y alone is to divide by 3. And there's my inverse. Okay, so don't let fractions be your downfall. You can do this. Just got to keep working at it and playing at it a little bit. Find the remainder. Now remember, we're doing synthetic division on this. So when we do synthetic division, we switch the sign. That -2 becomes plus. You're like, why is that? Because what we're doing is we're dividing by what's called a 0, or an x-intercept. And so if I actually solved this, that's where the 2 is coming from, that I'm going to divide by. So I make sure there's no gaps. There's not. And I bring this first term down. That never changes no matter what the first number is. And then I'm going to multiply, put it in the next slot, and add down. Take my answer and multiply by the 2, put that in the next slot, and add down. Multiply, and add down. And when it asks to find the remainder, all we want is the number at the end. I could pull it in, plug in all the x squared and the x, but all I want when it says find the remainder is the number at the end, and I'm done. So for 5 and 6, state if the given binomial is a factor of the given polynomial. Okay, in other words, do I get a remainder of 0? So I go back here and I go, okay, now let's see. Switch my sign. No gaps. And I'm going to bring my terms down and go. So, I got 1 down. 1 times 7 is 7. Add down. -8 times 7 is -56. Add down. 1 times 7 is 7. Add down. I didn't get 0. So no, that's not going to be a factor of the given polynomial. Okay? If I get a remainder of 0, it's yes. Otherwise, it's no. And let me tell you, when we get to 7 and 8, I'm going to give you a little bit of an insight here moving forward towards the final. The questions on the final I have to this can be used with synthetic. So I'm not going to worry about this with you because it's one less thing for you to worry about. So good news of the day. I'll let you whack a couple. Don't tell anybody. So then I get over to the back, and I'm supposed to go find some zeros here. Now, when we've been looking for these before, zeros, otherwise known as x-intercepts. I'm going to go to the calculator. I'm going to plug my expression in. And I'm going to graph it. Now, the zeros are where it crosses the x-axis. So we talked before, and this is a little scrunched, so maybe I'll change my window up a little bit. Maybe we'll say 0 to 10. That may not have been my best idea ever either. See, sometimes life, especially in math, can kind of go into a guess and check. Okay, that's a little easier to see. But I'm going to do second, trace. Okay, so second, trace. And in this case, I want number 2, which is the zeros. And we talked before about how we're going to trap them. Now you're like, well, maybe I'll get lucky if I look in the graph. And you're like, you know what? That was even smarter than what I thought. Because I look at the chart and I'm like, oh, find all the zeros. Okay, we got one at 0, 0. We've got one at 1, 0. Shoot, are we going to, well, didn't even have to worry about all that other thing with second and trace and all of that. Sometimes I'm going to get fortunate and all my zeros are just going to pop up that way. But if I would have needed to, let me actually find one of them with you that way anyway, just so you can see, even though we know what they are. Let's say I was looking for this one. What I would do is I would take my little cursor guy and I'd come over here. And when I thought I was pretty close, I'm going to click a couple of times to the left, hit enter, a couple of times to get back where I started, and a couple more to the right. And if I hit enter not once, but twice, okay, I see, oh, it's at 3, and I'd already found that using the chart. So the chart's a good idea when we're going to go ahead and do that way. For my mins and my maxes down here, same thing, second and trace. We're just going to use a different part in the menu. So negative x to the third plus 4x squared minus 5. So look at my graph. Now again, if I didn't change my window back, because maybe some of you will be using your calculator, maybe you didn't do the last one, you just kind of watched me. So let me get it back here where we can see. Okay, we're back to normal. And again, if you're ever not at normal with the calculator, if it looks weird, you can always get it back to this stage by just hitting zoom and going down to number 6, and it'll get you to the same place. But okay, we need to find the min and the max. Second trace, there's my min and my maxes, so let's just find the min first. Okay, well, that looks pretty good actually. Couple to the left, enter, 1, 2, 3, 4 to the right. Now remember, E is a fancy way of saying 0 because it's just doing scientific notation. So my min is at 0, negative 5. And then I start the process over again. I want to find the max. I scroll over until I'm pretty much at the top. Do a couple clicks to the left, enter. 1, 2, 3, 4 to the right. Enter twice. And my max is at 2.6, oops, 2.7, I'm sorry, I'm rounding the nearest tenth, and 4.5. And I get both of those. So again, nothing that's too terribly awful. Factoring we've seen, and then we've seen again. Remember your golden rule. If there's something in common, I'm just going to say this on 14, quick thing. Factor out what they have in common first. It'll make your factoring a lot easier. That's all. A polynomial function with rational coefficients has the following zeros. Find all additional zeros. Okay, all that means is we take what's called the complex conjugate. You just change the sign of I. Change the sign of I. Okay? That's all you have to do. You don't have to plug anything in the calculator, nothing fancy. Just change the sign of I, write another one, you're done. Not bad, not bad, not bad. And finally, we'll do one down here at the bottom, working with square roots. Let's do 21. Got to get x squared alone first. And I got a square root to get rid of the squared. Now, let's see, what do I have to pay attention to here? How many answers am I going to have with this quadratic? Exponent of 2 means there's 2 answers, plus minus. All right. Now, I know 3 doesn't break down, so I've got that. Now, how do I deal with that negative again? Can I punch in the calculator? No. Do I ignore it? No. Oh, yeah, we're going to pull an I out. And I'm set. So that's it here on this review. We are going to talk about one more next week on circles, but we'll talk about that when we get there. Keep working hard. It's going to be worth it.